Card shuffling. Taking a deck of cards and mixing them up so that their new order is random and independent of their starting order. There are a number of techniques for shuffling cards, all with varying levels of effectiveness when it comes to randomising the order of the cards. One of the best and most popular techniques is the riffle shuffle, which mixes up the cards pretty well. However, to achieve a deck order that is completely indistinguishable from the previous order, you need to do a good riffle shuffle about 7 times in a row. Realistically, no one is bothering to shuffle for that long. But why does randomness of card order matter? Well, one example is for trick-taking games like whist or bridge. For these games, players have to follow suit if they can, meaning that when a card of one suit is played, other players must play the same suit. High cards are often also played on top of other high cards. As a result, the deck at the end of the hand is much more grouped together and ordered than at the start. If you didn't shuffle these cards at all, this relatively well-ordered deck would deal relatively well-ordered hands, which would make for a fairly boring game. Games like this are generally best when you have an interesting card distribution. If you shuffle badly, you will see the same effect to a lesser extent, as the cards will still be more ordered than a truly random deck. Good shuffling is especially important at casinos. Casinos often use expensive shuffling machines to completely randomise the deck order each time. These machines don't just mix the cards around until the order is random, but separate each of the 52 cards and select a new random order for them, ensuring there is no relation between the pre- and post-shuffled decks. I'd like to have a machine like this, but I'm not willing to drop 10 grand on one. So my plan is to make my own for much cheaper. My shuffling machine will need to have 3 main functions. It needs to separate the cards from a deck into 52 individual cards. Then it needs to randomise the order of these 52 cards, and then it needs to combine them back into one deck. I started out working on a card separator. My first design had a stepper motor connected to 2 grippy wheels mounted on linear rails above the deck of cards. However, it quickly became clear that this was not going to have the control needed to eject just one card at a time. My next design moved the cards above the stepper motor, and this showed more promise. I tweaked some of the fits and reprinted it as a modular design to allow more adjustments. I also added a wooden dowel which only allows one card to pass through at a time. After some minor adjustments with a Dremel, I was ready to test. This was a great success, however, towards the end of the deck it started to struggle to keep ejecting cards. I realised this was due to there not being enough weight from the cards above to push the bottom card down against the ejector wheels. I printed a top piece with slots in to hold M10 nuts to add some extra weight. This turned out to be overkill and made the card ejection significantly worse. After some experimenting, it turned out that all was needed was a relatively thin plastic piece, alongside some adjustment to the motor timings and the fit of the wooden dowel. With the ejection system working, the plan now was to make a rack to store the separated cards. This rack is mounted on some aluminium extrusion and can be raised and lowered with a lead screw powered by a stepper motor. I did some quick tests to make sure the lead screw was working and then got on with making the rack. An important part of the rack design that I haven't shown yet is the release mechanism. For this I printed 52 individual levers, the idea being that once the cards are in the rack, these levers can each be pulled individually to release a single card from the rack. I attached an elastic band to each one and mounted them onto a threaded rod. I hooked the other end of each elastic band to a series of pins and the levers were now spring-loaded. I printed and assembled a rack, but it quickly became clear that I had somehow messed up the alignment between my card slots and my levers. The bottom slot aligned well with the bottom lever, but the top slot was well off. I now had to either redesign and reprint my card rack or my set of levers. I decided to set about dismantling the lever system and try some other card release options. I mounted the pieces I had so far on some temporary wooden stands and made a door that could be activated with a servo motor. I loaded the rack up with cards by hand for a test run, which was less than successful. It was clear that my design needed a rethink, and at this point I realised that I was overcomplicating things by trying to make the most complex part of the design, the card rack, also be the part that moves up and down. Instead, I could mount the card ejector to the lead screw and move this instead. After testing this setup for a while, I realised I was getting occasional misfires from the card ejector, which I couldn't eliminate with any amount of tweaking. To fix this, I installed an extra module with a light gate for the card to pass through. The ejector now attempts to eject a card, then checks whether the light gate is triggered. If not, it will continue to attempt to eject cards before moving on to the next position. With the card rack no longer needing to be raised and lowered, I can make the design much chunkier. I printed the main rack in 4 sections. These are bolted together using brass inserts which are heat staked into the prints with a soldering iron. After mounting the ejector and card rack to wooden stands, I started testing whether I could accurately dispense a card into each slot. For now, I'm just attempting to fill every slot in order. I'll worry about randomising the order later. Remarkably, this test worked pretty much first time, and the ejector seemed to have stopped misfiring as well. I now needed to focus on gathering the separated cards back into a deck. I repurposed my Perspex door idea from the earlier design to hold the cards in the slots. This time, however, I designed a carriage to hold the door and collect the cards. This carriage runs on 2 rails and interfaces with 2 rack gears that I attached to the sides of the main card rack. 2 continuous running servo motors are mounted to the carriage to allow it to climb up the side of the card rack. At this point, I was starting to feel confident enough that this shuffler might actually work, so I gave it a card table themed makeover before testing out the deck gathering mechanism. With the whole shuffler now assembled, I tested ejecting all 52 cards in order to make sure everything was aligned correctly. All that was left to do now was to randomise the order of the cards. To do this, I used the Fisher-Yates shuffle algorithm to pick a random order for the slots. The card ejector then travels to each of the slots in the selected order. With this implemented, I had a fully functioning, true random card shuffler. The shuffler isn't exactly quick. A full shuffle takes around 5 minutes start to finish. What you're watching here is in 32 times speed. So far, I've done all my testing on one deck of red bicycle cards. I wanted to see how it would handle a brand new deck, fresh out the packet with all cards completely ordered. Interestingly, the ejector started misfiring a lot more with the brand new deck. It seems that the new cards being more slippery makes the ejection system less reliable, so it was definitely worth adding the light gate module. Other than a few wire snagging issues during card ejection, which required some intervention, the shuffler managed to shuffle the brand new deck. A bit of extra electrical tape for cable management sorted the issue for future use. So, it's pretty noisy and it's pretty slow, but in the end I'm actually very proud of this contraption. I have ideas of how I can make it smaller, quicker and quieter, as well as a bunch of other project ideas, so please subscribe if you find this kind of thing interesting.